ፋሲሊደስ ኢንተርናሽናል ቻናል ተከታታዮች እንደምናችሁ እንኳን ወደ ፋሲሊደስ ኢንተርናሽናል ዩቲዩብ ቻናል የ12ኛ ክፍል የሂሳብ ትምህርት በሰላም መጣችሁ። እኔ መምህር የማታው ነኝ። እንግዲህ ዛሬ የምንማረው ከባለፈው ትምህርት የቀጠለውን lesson ነው። lesson 8 ማለት ነው። lesson 8 which is geometric sum of geometric sequence ማለት ነው። ካሁን በፊት the sum of arithmetic sequence የሚል አይተናል lesson 7 ማለት ነው። So today we are going to see the sum of geometric sequence in the So the main objective here is that how to derive the summation, the formula of sum of geometric sequence, and to find the sum of the sequence which is in the form of geometric sequence. ያሉትን ድምራቸውን መስራት እንችላለን፣ ፎርሙላውን ዲራይቭ ማድረግ እንችላለን ማለት ነው። ስለዚህ ይሄን በጥሞና እንድትከታተሉን እየጋበዝኩኝ ምናልባትም ይሄ lesson ከተመቻችሁ ሼር፣ ላይክ እና ኮሜንት ማድረጋችሁ ወይም ደግሞ ሰብስክራይብ ማድረጋችሁን አትዘንጉ። Sum of geometric sequence that you have to recall that the geometric sequence recall that the geometric sequence if we have to have G1 G2 G3 up to say GNB geometric sequence or geometric progression, we can say the ratio between any consecutive terms are constant. In this case, the nth terms of the sequence Gn, the general term, Gn is exactly equals to G1 times r to the power of n minus 1. ይህም ብለን ነበር እንግዲህ ታስታውሱ ከሆነ ከአሁን በፊት ስንማር ስለ ጂኦሜትሪክ ፕሮግሬሽን ወይም ደግሞ ጂኦሜትሪክ ሲኩዌንስ እና G1, G2, G3 up to Gn geometric sequence ወይም geometric progression ከሆነ the nth general term of the geometric sequence can be calculated by the first term G1 times r to the power of n minus 1 የሚለውን ለማየት ሞክረናል። Now today we will see that the sum of say G1 plus G2 plus G3 up to say Gn, especially the finite sum of geometric sequence የሚለው ነገር እናያለን ማለት ነው። Therefore we can say here Sn is equals to say G1 plus G2 plus G3 plus up to say Gn. ምን ይሆናል የሚለው ነገር እናያለን ማለት ነው። So this implies that from this we can say Sn is equals to G1 plus, but G2 means by this formula the nth term equals to G1 times r to the power of n minus 1. So G2 means r times G1 plus G3 means r square times G1 plus up to say Gn, but Gn means calculated here G1 times r to the power of n minus 1. R to the power of n minus 1. So this let it be this is star, which means the partial sum of the geometric progression is calculated by G1. Sn equals to G1 plus G2 means r times G1 plus G3, but G3 means r square times G1 plus G4 means r cube times G1 plus up to Gn means r1 times G1 times r to the power of n minus 1. Now from this part, if we multiply on both sides of this equation, this star by r, we can say r times Sn, which equals to here r times G1, say we can say r times G1 plus, and from this multiplied by r, we have here r square times G1 plus, from this multiplied by r, so r cube times G1 plus. When we multiply this by G1, r, so we can say G1 plus G1 times say r to the power of n. how this is happened, class? How this is happened? Because of way G1 times r to the power of n minus 1 multiplied by r means G1 times r to the power of n minus 1 plus 1. So this meant by the rule of say a to the power of n times a to the power of say m for two exponents in the form here, the same base with different exponents. With the operation of multiplication, we have take one from the base and the sum of from the exponents is that a to the power of n times a to the power of m means a to the power of n plus m. In the same fashion here, r to the power of n minus 1 times r to the power of 1 means this r to the power of 1. So G1 times r to the power of here n minus 1 plus 1, this should be cancelled out, so which is simply r to the power of n. Therefore here, this G1 times r to the power of n minus 1 multiplied by r equals to say G1 times r to the power of n. So then left with this is step 2. When we come to here, when we subtract the equation 1 or equation here denoted by star and the second equation which is star 2, we can subtract which is equals to this implies that Sn minus r times Sn, we have Sn minus r times of Sn, which equals to here r times G1 minus r times G1, this is cancelled out, and r squared times G1 minus r squared times G1, this is cancelled out. So the previous here r cube times G1 should be or will be cancelled out by r cube times G1. So everything is cancelled out. And again, before G1 times r to the power of n, we have to have here G1 times r to the power of n minus 1. So this term will be cancelled out here by G1 times r to the power of n minus 1. So what's left is that here the first part here G1 and the last part here is G1 times r to the power of n, which means G1 times G1 minus here it is G1 times r to the power of n. Now if you take from this, which is the common part here, Sn minus r times Sn, we can say 1 minus r times of Sn as a common factor. This is exactly equals to here G1 into 1 minus r to the power of 1, I mean n, as a common factor, because G1 times 1 is G1, so G1 times r to the power of n is G1 times r to the power of n. Now, what we need is that the sum, what will be the sum of the nth terms of the geometric sequence? So divide by 1 minus r and divide by 1 minus r as common. So from this part Sn is exactly equals to here G1 times 1 minus r to the power of n over 1 minus r, meaning when you divide on both sides by 1 minus r, we will get Sn equals to G1 times 1 minus r to the power of n over 1 minus r, provided that here r should be different from 1. R should be different from 1. Actually, we will see later on what will happen if r is exactly equals to 1. So this is a formula. This is a formula class. When this is, we call it the sum of the first n terms of the geometric progression. The geometric sequence or the geometric progression can be calculated by the formula Sn equals to G1 times 1 minus r to the power of n minus over 1 minus r. ስለዚህ እንግዲህ ከዚህ በኋላ የምታዩት ዓላማችን እንዳያችሁት ጂኦሜትሪክ ሲኩዌንስ ወይም ጂኦሜትሪክ ፕሮግሬሽን ቢሰጠን እነዚህን እንዴት ነው በቀላሉ ልንደምር የምንችለው የሚለውን ነገር ለማየት ነው እዚህ ጋር የሞከርኩት ማለት ነው። ስለዚህ ሰሜሽኑን ወይም ድምሩን Sn ብንለው ፓርሻል ሰም ስለሆነ the nth partial sum of the geometric progression is given by simply G1 plus G2 plus G3 up to G1 ነው Gn ነው። ነገር ግን ይሄ Sn G1 አለን እዚህ ጋር ግን G2 ማለት በዚህ ፎርሙላ መሰረት the nth geometric progression can be calculated by G1 times r to the power of n minus 1 ብለናል ካሁን በፊት። let's say G2, say for example, G2 equal n is 2, so G1 times r to the power of 2 minus 1. 2 minus 1 is say simply 1, so r to the power of 1, which means r, so that G1 times r is G2. So instead of G2 is say r times G1. So instead of G3 is r squared times G1. So instead of G1 is Gn is G1 times r to the power of n minus 1. Now ይሄን አንደኛው ኢኩዌሽን ብንለው ወይም ደግሞ ስታር ብለን ብንሰይመው ይሄንን ኢኩዌሽን both sides ለሲምፕሊፊኬሽን እንዳመቸን both sides በr ብናባዛው so Sn times r, r times Sn, G1 times r, r times G1, r times G1, so r times r square times G1 እያለ እስከ መጨረሻ ሄዳል። እዚህ ጋር ስንደርስ G1 times r to the power of n ይሆናል ማለት ነው። እና ምንድን ነው ያደረግነው እዚህ ጋር ሰብትራክሽን የመጀመሪያው ኢኩዌሽን ላይ ሁለተኛው ኢኩዌሽን መቀነስ ነው። ስለዚህ Sn minus r times Sn ይሄን አገኘን። ሶ ከዚህኛው ኢኩዌሽን ላይ ይሄኛውን ኢኩዌሽን በምንቀንስበት ጊዜ ምንድን ነው ያገኘነው? እያንዳንዱ ውስጥ ያሉት ተርሞች ከሁለቱም ኢኩዌሽን እርስ በርሳቸው ካንስል አውት ነው። ከመጀመሪያው ኢኩዌሽን G1 ብቻ ነው ሌፍት የቀረን። ከሁለተኛው ኢኩዌሽን G1 times r to the power of n ብቻ ነው የቀረን። ከዛ በኋላ እሱን ከወሰን ኮመን ፋክተር እዚህ ጋር Sn እና ኮመን ፋክተር ያለው እዚህ ጋር G1 ነው። ስለዚህ both sides ለ1 minus r ስናካፍለው Sn equals to G1 times 1 minus r to the power of n over 1 minus r የሚለውን እናገኛለን ማለት ነው። እንግዲህ በዚህ ፎርሙላ መሰረት የማንኛውም ጂኦሜትሪክ ፕሮግሬሽን ቢሰጠን ሲኩዌንሶቹ ጂኦሜትሪክ ናቸው ከተባለ እና rን ዲተርማይን ካረግን እንዲሁም ደግሞ የፈርስት ተርም G1 ካገኛል ለምሳሌ any geometric progression ቢሰጠን እና the nth partial service ካልኩሌት አድርጉ እንባል ለምሳሌ 100ኛው ተርም 10ኛው ተርም 25ኛው ተርም 50ኛው ተርም ካልኩሌት አድርጉ እንባል ስለዚህ የመጀመሪያዎቹ 50 ተርሞች ድምር የመጀመሪያው 100 ተርሞች ድምር የመጀመሪያው 10 ተርሞች ድምር ብንባል ስለዚህ ይሄን ፎርሙላ ተጠቅመን መስራት እንችላለን ማለት ነው። First example is that find the sum of of 5 plus 10 plus 20 plus 40 plus 80 plus 160 plus 320 plus 640. All these are equals to how much class? እንግዲህ ይሄን ኖርማሊ ይሄ ቁጥር ቢሰጣችሁ እንደዚሁ ካልኩሌተር ይዛችሁ or something እያሰላችሁ መደመር ትችላላችሁ። ነገር ግን የሚላችሁ ዓላማ ምንድነው? ይሄ ሲኩዌንስ ይሄን ለመደመር ሲኩዌንሶች ወይም ክትትሉ እንደምታዩት ጂኦሜትሪክ ነው። ሶ ጂኦሜትሪክ መሆኑን ካወቃችሁ የጂኦሜትሪክ ፎርሙላውን አፕላይ አድርገን እንዲሰራ ነው። እዚህ ጋር እንደምታዩት as a solution here the first term is 5, second term is multiplied by here 10 divided by 5 is 2, 20 divided by 10 is 2, 40 divided by 20 is 2. So this is common number. That common number what we call common ratio, that is r. So this is the geometric progression. The sequence is geometric progression with r equals to 2 and with the first term G1 is 5. What is the value of n? N means the number of terms of the sequence. So which is say we can count it 1, 2, 3, 4, 5, 6, 7, 8. So the number of terms of the sequence is say 8. Look. So what we need to show that what is the sum of all this? All the የነዚህ ሁሉ ድምር in a simple way እንዴት ነው መደመር የምንችለው የሚለውን ነገር ለመስራት ነው። So we can say the formula is say Sn. So Sn is calculated by the sum of the partial sums of what the geometric sequence can be calculated by the first term G1 multiplied by 1 minus r to the power of n over 1 minus r. Now you can substitute. Also what we need is that what is S8, the first 8 partial sum of the sequence. What is G1 is given here say 5, so 5 into 1 minus which is r is given here it is 2 to the power of 8 over say 1 minus 2, 1 minus r, the value of r is also, which is exactly equal to 2. Now, so which is equal to 5 times 1 minus to the power of 2 means 256 over here 1 minus is -1. So which is equals to 5 into 1 minus 256 is as you know equals to -255 over say -1. So the result is when multiplied by say 5 times 255, so 5 times 5 is 25, we have 2, again 5 times 5 is 25, we have 2 plus 2 which is 7, and again we have 2 also, so 5 times this 2 is 10, plus 2 is 12, so which is -1275 over -1, so negative by negative is cancelled, our result is 1275. እንግዲህ ምንድነው ይሄ እንዳያችሁት በቀላሉ ኤስኤንን ካልኩሌት አድርጎ ነው የተደረገው ኤስ8 ስለዚህ ፎርሙላችን ኤስኤን ማለት j1 ታይምስ 1 ማይነስ r ዘ ፓወር ኦፍ n ኦቨር 1 ማይነስ r ስለሆነ n ተሰጥቶና 8 ተርሞች ድምር ማለት ነው እንግዲህ ፈርስት ዋን j1 ተሰጥቶና ፈርስት ተርሙ ማለት ነው common ratio አትሰጥተናል በእነሱ በፎርሙላው መሰረት የተሰጡን ጊቨን ኳንቲቲዎች አስገብተን ሲምፕሊፋይ ስናደርግ የዚህ ውጤት 1275 ሆኖ እናገኛለን ያ ማለት 5 ሲደመር 10 ሲደመር 20 ሲደመር 40 ሲደመር 80 ሲደመር 160 ሲደመር 320 ሲደመር 640 ማለት ነው 1275 ሆኖ እናገኛለን ማለት ነው find the sum of the first 10 terms of the series. You see the sequence series 3 minus 6 plus 12 minus 24 plus 48 and plus here in such a way. What will be all this? The first 10 terms. Now, Miller Mindana, what will be the sum of 3 minus 6 plus 12 minus 24 plus 48? ይሄ እንግዲህ እንደምታዩት ክትትል ነው ወይም ደግሞ ሲኩዌንስ ነው ምን አይነት ሲኩዌንስ ነው ማለት እንችላለን let's say -6 divided by 3 is -2 and 12 divided by -6 is -2 and -24 is divided by 12 is -2 so all this no doubt it is geometric sequence ስለዚህ ክትትሉ geometric ክትትል እንደሆነ እናውቃለን So as a solution here, we are given here it is the geometric progression. The geometric progression with the first term j1 is equal to 3 and the common ratio r is -2. Now and also we are asked to find the first 10 terms of the sequence, which means the value of n is equal to say what 10. So what we are asked to find is that the value of S100, I mean S10, the sum of the first 10 terms of the sequence, what would be? ስለዚህ የተጠየቅነው የተሰጡ ነገሮች ምንድናቸው እንግዲህ ክትትሉ ጂኦሜትሪክ ክትትል ነው ወይም ደግሞ ጂኦሜትሪክ ፕሮግሬሽን ነው ጂኦሜትሪክ ሲኩዌንስ ነው ፈርስት ተርሙ ወይም ጂ1 3 ሆኖ ኮመን ሬሽዮ -2 እንደዚሁም ደግሞ የተጠየቅነው ምን ደብራቸው ብዛታቸው የተርሞቹ ብዛት 10 ሆነው ነው 10 ናቸው ስለዚህ የተጠየቅነው S10 ይሆናል ማለት ነው the sum of the first 10 terms of the sequence ማለት የመጀመሪያዎቹ 10 ቁሞች በዚህ ክትትል ላይ ማለት ነው የመጀመሪያዎቹ 10 ቁሞች ድምር ስንት ነው ብሎ ነው የጠየቀን ማለት ነው ይሄን ለመስራት እንግዲህ as a solution SN ማለት በተሰጠነው ፎርሙላችን መሰረት ካሁን በፊት ያየነው Sn equals to G1. So be sure that you have that the sequence is geometric. So Sn equals to G1 times 1 minus r to the power of n over 1 minus r የሚለው ፎርሙላ አለን ማለት ነው። So what we need is that S10 means the sum of the first 10 terms of the sequence. So which is geometric sequence. So the first term is say G1 is equal to say 3. So 3 into 1 minus common ratio r is say -2. So here -2 times of n, but the value of n is here, it is 10. So all this over it is 1 minus r. 1 minus r is given also, which is a -2. We have now what's left is to simplify all these expressions. So this expression equals to simply 3 into 1 minus here minus 2 to the power of 10 is equal to, we know that 124, or I mean 1024 over here it is 1 minus 2 becomes 1 plus 3. Here we know that 1 minus 2 means it is plus, which equals 3. So the result is 3. Now from this part we can say here 3 with 3 is cancelled out or simplified. So 1 minus 1024 becomes negative, which is 1023 ብሎ እናገኛለን ማለት ነው። ስለዚህ የመጨረሻው ውጤታችን ኔጌቲቭ 1023 ነው ታገኙታላችሁ ማለት ነው። ስለዚህ አሁን ጥያቄ በዚህ መልኩ ስትሰጡ መጀመሪያ ኦብዘርቭ ማድረግ ያለባችሁ ወይም ማየት ያለባችሁ ምንድነው የተሰጠው ክትትል ጂኦሜትሪክ ነው አይደለም? እሱን ማየት ተጠበቅብና ጂኦሜትሪክ ከሆነ ፈርስት ተርሙ ማን ነው? ኮመን ሬሽዮ ማን ነው? እና የመጀመሪያ ስንት ተርሞች ነው እንድንደምር የተጠየቅነው የሚሉት ነገሮች በደንብ ካየን በኋላ የፕሩፍ ያደረግነውን በፊት ፕሩፍ ያደረግነውን ፎርሙላ እሱን ተጠቅመን which is Sn equals to Gn times 1 minus r to the power of n over 1 minus r የሚለውን ፎርሙላ ተጠቅመን በቀላሉ ካልኩሌት ማድረግ እንችላለን ማለት ነው። The third example is says that given the sequence let's say 1 say 3 9 27 and extra like this, so that we can say find the value of a, say S5, and again b can be say S10. So here given a sequence like this, say 1 3 9 27, so as we observe that here the sequence is what kind of sequence? Simply you can observe by the factor which is say 3. So 3 divided by 1 is say 3, 9 divided by 3 is 3, 25 divided by 9 becomes say 3. So no doubt it is geometric sequence. So that what you are asked to find is that, so what will be say S5? S5 means the sum of the first 5 terms of the given sequence, which means 1 plus 3 plus 9 plus 27 plus the next 81. And again here it is say S10. S10 means the sum of the first 10 terms of the sequence የሚለው ነገር ነው እንዲሰሩ እንዲተጠየቃችሁት ማለት ነው እናንተ። Therefore, as a solution we can say this is a sequence. This is a sequence with geometric sequence with the first term is G1. G1 is equal to say 1 and the value here for the value of say r is equal to say 3. For here the value in b, and for calculating S5 a part, so n is 5. So we are asked to find this S5. So S5 calculated by Sn, which equals to say G1 times 1 minus r to the power of n over 1 minus r. So this implies S5 is exactly equals to G1 is 1 into 1 minus r is 3 is the power of 5 over 1 minus 3, because the value of r is exactly equals to 3. So from this part, which equals to say 1 times 1 minus here it is 3 to the power of 5 is 243 over 1 minus 3 is equal to say negative 2. So the result is 1 minus 243 means so negative 242 over negative 2. When you simplify here, negative with negative is cancelled out. So the result is when 242 it can be divided by 2, your result is 121. So which means here the sum of the first 5 terms of the given sequence determined in such a way is calculated by the result 121 Now to determine the value say S10 means the sum of the first 10 terms of the sequence here. So we can calculate here as S10 which is equal to simply G1. The first term 1 into 1 minus common ratio 3 the power of 10 over 1 minus common ratio r, which is equal to say 3. So this equals to 1 times 1 minus 300 3 the power of 10 means simply 1 minus 59,049 over here it is negative 2. So when you subtract 1 from say 59,049, which equals to negative say 59,048 over so negative 2. So the result which is equal to say negative with negative is cancelled out. So the result is 29,524 when you simplify or when you divide or this by 2, the result negative with negative is cancelled out. So your answer should be 29,524. ስለዚህ የምታረጉት በጅዋን ቦታ ዋንን ተካሁኝ በአር ቦታ ስሪን ተክቼ ኤን ደግሞ እዚህ ጋር ምክንያቱም ኤስ 10 ስለተባልኩኝ 10 ተካ። ስለዚህ 10 ኃይለ ቁጥር 3 ኃይለ ቁጥር 10 ማለት 3ን 10 ጊዜ ኃይለ ቁጥር በምናደርግበት ሰዓት የምናገኘው ውጤት 3 ሲባዛ በ3 ሲባዛ በ3 ሲባዛ በ3 ሲባዛ በ3 10 ጊዜ ስናባዛ የምናገኘው ውጤት 59049 ሆኖ እናገኛለን ማለት ነው። ስለዚህ ከአንድ ላይ 59049 ስንቀንስ ኔጌቲቭ 59048 ሆኖ እናገኛለን። ነገር ግን አንድ ሲቀነስ 3 ኔጌቲቭ 2 ነው። ሶ ኔጌቲቭ በኔጌቲቭ ይጠፋና ፖዚቲቭ ይሆናል። ሶ 59048 ለሁለት ስታካፍሉ 29524 ነው እናገኛለን ማለት ነው። An exercise here, if the first two terms of a geometric progression, a geometric progression, or we can say geometric sequence is given by say 2 and 4 respectively here, 2 and 4. Then find A, so S10, B, S20, and C part say S100. So you can calculate, you have to apply the formula what you have learned before, which is if it is the sequence is geometric and given the first terms and the common ratio. So what will be the summation of the S10, S120 and S100, which means you can calculate S10 means the sum of the first 10 terms of the given sequence, which is geometric, and S20 means the sum of the first 20 terms, and also S100 means the sum of the first 100 terms of the given sequence, which is geometric sequence ማለት ነው። ስለዚህ S10 S20 S100 ማለት እንግዲህ ምን ማለት ነው? የመጀመሪያዎቹ መቶ ተርሞች ድምር ስንት ነው ተብላችሁ ተጠየቃችሁት ማለት ነው። ያ የተማርነውን ፎርሙላ በአግባቡ ማስታወስና መጠቀም እንዲሁም አፕላይ ማድረግ ይጠበቅባቸዋል ማለት ነው። በሚቀጥለው ትምህርት ክፍለ ጊዜ ወይም ለሰን እስከምንገናኝ ድረስ ሰላም ሁኑ።